Welcome, everybody. Thank you for joining us today. Before we get started, a quick note, this session will be recorded and will be posted on YouTube. So if you're watching from YouTube, go ahead and hit the like button and subscribe. It helps us get this content out to more people who need it. For everyone joining live, welcome to the Factory Migration webinar from complex VM estates to OpenShift virtualization. My name is Todd Millard. I am the CEO of Crossvale, soon to be part of the Options IT family. We are a container platform engineering and managed services company with operations across US, UK, and Spain, and we specialize in Red Hat OpenShift. Joining me today is Jose Alonso, our CTO, who will be taking us through the technical walkthrough later in this session. Here's what today's about. The private cloud platform landscape is changing, fundamentally, not incrementally. Enterprises that have built their infrastructure on VMware are facing a real decision point. Today, we are going to give you the context you need to understand what has changed, a practical methodology for what you can do about it, and real outcomes from organizations that have already made the move. We have a lot to cover and a specific offer at the end that will be worth staying for. So let's get rolling. All right, so here's our agenda for the next 50 minutes. Section 1 is the platform landscape. We'll set the context for what has changed with Broadcom and VMware and why it creates a decision point for your organization now. Sections 2 and 3 are methodology and tooling, the factory migration model, the economics, the engineering engine underneath it. Section 4 is Jose's technical deep dive. He'll go into a deep dive to talk in more detail about this solution. In section 5, we can talk about real world use cases. I'll send this deck out afterwards as well. So if we don't get to all the use cases, you can review them additionally on your own. And section 6 is our Q&A and the offer. I want you to stay for the offer. The offer is really compelling. If you're looking at making a change in the next 6 months in your infrastructure, you'll want to stay and see what that offer is all about. So a quick introduction to who we are and why the combination of Options IT and Crossvale is unique in this market. Options IT is a global IT managed services company, US headquarters in New York, global headquarters in London. They built Horizon Private Cloud, dedicated enterprise-grade, multi-region private cloud infrastructure built specifically for complex and regulated environments. Options IT is a VMware Pinnacle partner. They operate within the Red Hat ecosystem, and they have a fully OpEx consumption model, meaning no capital expenditures for you when you're looking for private cloud. Crossvale is a container platform engineering firm, and we've been focused on container modernization since 2017. We hold 3 Red Hat OpenShift specializations simultaneously. This is the container platform specialization, or container platform management, actually, critical automation, and then also the application platform management. We have been recognized by Arrow as the 2025 Red Hat Managed Services Provider of the Year. When you put these together, you get something uniquely special that doesn't exist elsewhere in the market. One team that owns your entire journey from the first discovery scan of your VM estate all the way through the 24/7 managed operations in production. No handoff to a platform vendor and a migration vendor, one contract, one team, one outcome. Now let me set the market context for why this matters for you. So we take a look at what's going on. Broadcom has made deliberate and public strategic choice. And every enterprise with the VMware estate needs to understand what that means to them. So here's what Broadcom has stated directly. They are focused on a smaller set, this is their words, of highly capable, highly trained partners to deliver VCF. They have moved from over 4,500 cloud service provider partners down to a much smaller focused ecosystem. Basically, it's about 100 globally. So that's a lot that have been kicked out of that. They have simplified from 168 product bundles to 4, and VMware Cloud Foundation 9 is the unified platform. 87% of their top 10,000 customers are already on it. They are targeting Fortune 500 and highly regulated industries, finance, healthcare, government. This is a legitimate coherent strategy. So what does that mean for you, for your organization? There are 3 paths, the way I see it. Path A, you're a large enterprise with a direct Broadcom relationship. You fit their target profile. You are already on VCF9 or actively moving there. You probably don't need help at this point, unless you are looking for an economic or modernization solution that Path C offers. So Path B, you're on VMware technology, but your current hosting provider was not included in the new authorized program. You need a new authorized partner. Options IT is positioned to help you with that. And this transition needs to happen before April 2027 deadline. So you're scrambling to try to figure out how to solve this problem. Path C, your organization does not fit for the new VCF cost structure or model, or you want to modernize. The economics do not work for you at scale. You are looking for a modern hypervisor and container environment. OpenShift virtualization on Horizon Private Cloud is a good option for you there. So we're here to help you assess which path would be a great path for your organization. Many are finding that it's a great time to use this inflection point to modernize and move to path C, where they can run VMs and containers side by side. So let me frame the core problem before we move on to the solution, based off path B and C of the last slide, because this problem is important. When enterprises tackle VM migration the traditional way, every project starts from scratch. There's a team, whether it's internal or external, you build custom delivery scripts, argue about which VMs belong in which phase, manually validate the results, and then hand it off to operations, which sounds fine until you realize it means every project is unpredictable, every team learns the same hard lessons again, and every budget estimate is essentially a guess. This is why traditionally migrations chronically overrun. 40 to 70% budget overruns on complex projects are not outliers. They are the industry norm. 12 to 18 months for estates that should take 4 to 6 months. The factory model that we'll be talking about today industrializes this process, not because we skip steps, we do every step rigorously, but because we have turned every step into a repeatable, automated, scalable system. Our design target is approximately 100 virtual machines moved per day. Let me be precise about what that actually means. It is a throughput design target, not a contractual guarantee. Workload complexity varies significantly. Some VMs migrate in minutes, others, particularly the Windows workloads or machines that have very large disk footprints, require careful, warm migration with extended data copy phases. Additionally, the migration windows are controlled by your business, not us. So what the 100 VMs per day target tells you is the system is designed to be fast. A 500 VM estate should take weeks, not months. Well, let me explain to you more about the assembly line and how this is up to you as well as up to us. When we take a look at the assembly line that we put together, 7 stages, I'll walk through each one of these stages. Stage 1, discover. So we apply tooling that scans your VM estates. We capture CPU and memory utilization trends. We map storage, network dependency flows, OS versions, installed software, and service endpoints. We need to understand your environment. Stage 2, assess. We apply the 6R framework to every single workload. Every VM receives a data-driven score, not a gut feeling, not a spreadsheet estimate. This tells you exactly what percentage can be automated, what needs to be hands-on, have hands-on attention, and what should be retired. Stage 3, we plan. Dependency-aware wave planning. This is where migrations traditionally break down. Applications that depend on each other get split across different waves and break each other in production. Our dependency mapper ensures that interdependent workloads move together. Stage 4, we architect and provision the target environment. On Horizon Private Cloud, on your infrastructure, in public cloud, hybrid, whatever the need is for the architecture you need for your environment. Options IT Private Cloud runs in 70 different data centers globally, so there's a lot of options there. Stage 5, migrate. The execution engine, Red Hat migration toolkit for virtualization. Our design target is, again, approximately 100 VMs a day. That depends on your culture and the systems on how they interact. The actual rate depends on the workload complexity as well, the OS types, storage volumes, and the maintenance windows your business makes available to us. Stage 6, validate. Run test suites against migrated workloads before we declare completion. Limit manual verification. No hoping things work. Nothing gets marked complete until it passes. And then stage 7, operate. We transition over to PodOps, our 24/7 managed service, the day 2 operations that make this so you can do this entire transition without having subject matter experts in your ops team, because our team will be those subject matter experts for you and will be there day 1 to make sure you don't have critical failures. So the 6R framework is how we classify every workload in your estate. It is an industry standard framework that we've applied and refined throughout enterprise migration engagements. Jose will go over this in a lot more detail when he goes into his portion of this, but the key insight for most organizations is roughly 85% of your workloads, the rehost and replatform categories combined, can be moved using migration tooling with no or minimal code changes. So using tooling that is designed to be able to simplify this move, we can help you get that done. So in most cases, 85% of your workloads can move pretty quickly. You do not need to containerize your entire application portfolio to get onto the modern platform and start capturing the benefits. You run your VMs on OpenShift virtualization today, and you modernize applications at your own pace on your own timeline. We're finding most customers are finding at least a 30% savings moving from VMware over to OpenShift virtualization, fully managed. Important caveat, these percentages come from aggregate delivery data across industry engagements. Your environment would be different. The assessment would tell exactly what that looks like. So before we move to the walkthrough, let's review how to decide your next step. So we talked about path A. So that's option A, stay on VCF. If you're a large enterprise with a direct Broadcom relationship and you're already on or actively moving to VCF 9, you're Broadcom's target segment. VCF is a strong product. If you're okay running in the legacy VMs, this is a good option for you. But watch out for these 2 things. First, is your current hosting provider still authorized? If the answer is no, you need to move quickly. Your service path is ending. Second, if you're still on vSphere 7, the end of support date is October 2027. So you need to upgrade an upgrade plan regardless of which direction you go. So we go option B, transition to an authorized VMware partner. This is the path for organizations whose platform is fine, but whose provider was not included in the new ecosystem. The technology works, the delivery vehicle needs to change. Options IT as a Pinnacle partner can step you into your authorized VMware host and as your host and manage service provider. And then we can also work with you on how that modernization looks like over time. So you can start looking at your workloads to figure out what you want to modernize. But watch for just transitioning just because it's the easy thing to do. Right now, taking a look at whether this is the inflection point that works for you to focus on modernization. That's what we're seeing a lot of businesses do today. Option C, migrate to OpenShift virtualization on Horizon Private Cloud. You can run this actually in the options private cloud, public cloud, in your own data center. We will manage it for you. This is the path for organizations where the VCF economics simply do not work for you at scale. Companies often find that the 72 core minimum and subscription pricing creates a materially higher cost structure than their previous arrangements. Or organizations with a strategic preference for Red Hat OpenShift ecosystem, this is where the factory migration methodology and Horizon Private Cloud become the answer. The point of this entire slide is we do not have a one-size-fits-all recommendation. We help you figure out which answer is right for you and then execute whichever one that is. In fact, in some cases, it may be a mix of more than one strategy. A way to start quickly is to immediately start looking at your Linux workloads and start moving those over to OpenShift. That's the easy button. I will talk about some of the case studies that we have. So first of all, we'll describe where your workloads land. So after we're done with the live webinar, we'll be able to go through and talk about the options private cloud and where your workloads would land. But let's talk about customers who have made this move. So before we get into specific customer stories, I want to give you the market context of these. They're not small pilots or early adopter experiments. This is OpenShift virtualization customer count grew from 178% in 2024. Over $500 million in OpenShift virtualization contracts were signed between 2023 and 2025. In a single reference deployment, 9,000 VMs migrated in 6 months, and another 36,000 physical hypervisors replaced with a single unified OpenShift platform. The pattern is consistent. Enterprises in regulated industries, financial services, manufacturing, media, all making this move at scale, and the outcomes they're reporting are real and measurable. So let me walk you through some specific examples. So Emirates NDB, Dubai-based banking group, 13 countries, 9,000 VMware estate, core banking, payments, trading systems, databases. Their challenge was exactly the one that many are facing today. Rising VMware and Broadcom costs, forcing a platform decision. And I'm sure those of you watching this today can understand that. And they need a single unified platform that could run both their VMs and their containers across 13 countries. This is a big thing we're seeing organizations look for, is how do I run this together in a single platform so they don't have to have multiple different skill sets or different providers. They made the decision to migrate their entire VMware estate to Red Hat OpenShift virtualization, not a partial migration, everything. The execution was a wave-based migration, averaging 140 VMs per night across multiple data centers. In 6 months, their entire 9,000 VM estate was on OpenShift virtualization in full production. Their head of cloud compute, Ali Ray, said at Red Hat Summit in 2025, and I'm paraphrasing here, do not overthink it, just start. This is super important. Like getting in analysis paralysis, trying to figure out how to fix this, it can be a problem. One platform, VMs and containers unified, a banking group operating across 13 countries on one single control plane. That is what the factory migration model enables at enterprise scale. Jose, I see you're back. Do you want to try this again?
Yeah, I am back. Yes,
I'm gonna stop sharing so you can jump back in.
Okay, I had some internet issues. Okay, so can everybody see my screen?
Yes, we can see it.
Okay, so I don't know where I left. When did you stop listening? But
immediately, as soon as you kicked over, you immediately were gone.
Okay. So what we are going to focus today is on how do we make this efficient at the scale? How can we have multiple clusters in multiple data centers with migration of many VMs? This is not a single VM migration. There is nothing new there, and there are a ton of videos out there that you can watch. And if you're interested in looking at that, we can show you with a click button on the screen. What we are going to be focusing is on industrializing that process. So we are going to start from an empty cluster. We deploy a cluster. An OpenShift cluster comes with nothing. Well, nothing. It comes with OpenShift, but it doesn't come with everything that we need to be able to operate that cluster. On top of that, we do a platform deployment to make that cluster applications ready or VMs ready or both. We do then a tenant onboarding, assuming that this is going to be a multi-tenant onboarding, like a multi-tenant cluster where we have hosting solutions for multiple tenants, for multiple customers. As company, we want to host for different solutions, for different customers in a single cluster. And then at the end, we will also show how do we onboard applications and how would we manage those applications after they are onboarded. After that, I have a few slides going back into the workload scoring, the 6R classification, and some of the characteristics of how much do we want to do on analysis versus how much do we want to do on the actual migration. How long does it take to start migrating? I have recorded a video of the demo because our demo cluster is not at the place where it needs to be. So in this demo, I'm going to be stopping it to talk a little bit about what we are seeing. So for anybody who hasn't seen this before, this is an OpenShift console. Once you start an OpenShift cluster and you deploy, you will get a console like this, where you have on the left multiple places where you can go from applications, from observability, builds, networking, and then what in OpenShift is called projects. That is kind of like a namespace where we have workloads aggregated into that virtual entity. Then in the middle, we have a page that is going to be changing. Right now is at the cluster level. Depending on where we are, this view will change to show us what we want to see. And as you can see, once we have the cluster and we deploy our GitOps, everything that we do is based on GitOps. You will see now in a second how do we do it, our repos. So inside of the cluster, we create multiple machine sets. And these machine sets, you can create as many as you want. And the most important part is that you can reserve them. You can book them for different things. So in our example, we are going to tag some of these VMs to go to particular nodes. So assuming that you have the need of co-locating different workloads, you can co-locate them in those nodes. You can reserve nodes for a particular customer, or you can just share all of it. This is not a required step. It's something that we have by default. Now, we jump into the GitOps configuration, and as you see, we have this cluster where we are going to be deploying our ingress, and we are going to add it now into our tenants. So this is how we will be onboarding a tenant. everything is Git-based, so we are going to be pushing this into Git, and Argo, that is our GitOps operator, will automatically deploy. So you saw these are all the files that we are deploying. And now we are going to take a look at Argo. Once we do the Helm install, we are going to take a look at Argo to see how those artifacts are getting deployed. Okay, now we change to the proper namespace, the project that I was referring to earlier. And we go into the artifacts that we have deployed. And here you can see that now we have an ingress controller that is part of what we deploy for the multi-tenancy. This is it's important when we have multiple tenants to be able to separate traffic, to segregate traffic coming into the cluster to the different tenants. Once the deployment is in Argo, this is the Argo screen. I'm sorry, we missed it. This is the Argo screen. As you can see, there are things that are already deployed and things that are deploying. Once it detects a change in Git, it's going to automatically try to apply that to OpenShift. And this is something that is configurable. It can be automatic or it can be based on approvals. But the whole idea with this approach is that what we want is to have it all repeatable on a repeatable process. So when we deploy anything, we can repeat that in as many clusters as we want with the exact same configuration. So once we have a configuration that works for the cluster and for the customer, we can repeat it in every cluster. Argo and GitOps, you can have it in a way that it manages multiple clusters or it manages a single cluster. In this case, as you see, inside of the tenant virtualization, we have our dev cluster, and then we could have a test cluster, a prod cluster, and a DR cluster. And now for that tenant, that would be the configuration applied into the multiple clusters. Each cluster would know where to go. This is not the only way to do it. This is our way to do it. We have tested multiple ways, and we manage our platforms. So our PodOps, our managed service, has a lot of weight into how we do things in a way that minimize operations. It improves our operations performance. So this is one of the main reasons why we choose to do certain things the way we do it. This doesn't mean that you have to do it the same way. It means that for us, it is the best way. Once we create the tenant, now we are ready to onboard the applications that we want for that tenant. And that's what we are going to be doing now. Okay, now we push, and again, GitOps will automatically deploy that thing that we just pushed, that is to enable virtualization for this tenant. Now, this tenant that we onboarded now can deploy VMs. And what we are going to do now is to define how a VM will be onboarded. What do we need for that? We need storage, we need network, we need compute, right? So we are going to be defining the different configurations for those different components. So, well, and first we need the application. The application name in this case is Forklift. We are going to be using the Forklift operator under the Red Hat Migration Toolkit. We onboard the application inside of the same namespace again, so the namespace can use it. We, on top of this, we will then start creating the VM configuration. And lastly, we will do the VM migration plan. After we have the migration plan, we will start adding VMs into that migration plan, and we can migrate as many VMs as we want as part of that migration plan. The migration plan, typically we like to group VMs based on the type of VM that we are migrating. So in a migration plan, we shouldn't have 20 different types of VMs. We should group them in a way that makes sense from an application and architecture perspective. And once we have it inside of OpenShift, we can start going through the inventory, applying VMs to migration waves, and those waves would start going into OpenShift. You'll see that right now, what is happening is we are defining the source and the destination of migration. So we are going to be defining providers for virtualization. You can do all of this from the UI, from the OpenShift UI as well. You don't need to do it through GitOps. The beauty of doing through GitOps is that now, if I have 50 clusters or I have 3 clusters, I don't have to do it twice. I just apply the GitOps configuration and it will do it for me. Right now we have created vSphere and we are using a Red Hat environment for the source of these VMs. And we are going to be using the Red Hat image registry for the VMs as part of the destination and the Red Hat host as the destination for virtualization. So I'm going to accelerate this a little bit because now there is a lot of configuration going on. We have VMware, and now we are here. If you see, I'm going to stop it here. We now have the provider VMware with the credentials. So we are going to be mapping from a secret. We have the settings with the init image that we have it as this image from the registry. Then we have the network map. We are going to be mapping from here to here. And we have the storage. The storage, we are going to map the data store that is going to happen right now. We are going to use this data store that we have in the Red Hat demo environment, and we are going to be mapping it to one of our persistent volumes, our persistent volume providers inside of OpenShift. In this case, we are going to be just using host. This is one of our limitations in our demo environment. This has some consequences. We didn't have the proper access to the storage, which means that there are some things that we can't demo at the moment, and some things that we need to add. Now, once we have the application, because we pushed into GitOps and GitOps deployed, we have it now in the cluster and is ready. We don't have it to start automatically to start migrating VMs, but it will start based on click. So if we go into the left-hand side and we see the virtualization menu, we see that we have a catalog where we can create templates and deploy the different templates that we want. This is for going forward when we want to provision new VMs. This is not so much for migration, but for after we have migrated, how do we provision new VMs? If you see here, we have the catalog, virtual machines, or the virtual machines that are running. And here are the 3 objects that we were working with. We have the migration plan, the network map, and the storage map. Those 3 and the providers. Remember, we created 2 providers. One was VMware, the other one was OpenShift. We created the migration plan. We have created the network image, and we have, the network map and the storage map. So if we continue, we will go now into the migration plan. Okay, so that is the deployment that we have done through GitOps. As you can see, it's all synced, all green. We have created everything. And let's go back to OpenShift. We change to the proper namespace. And what we are going to be doing now is to add what do we want to migrate. We have created the tenant, meaning that we have deployed every application that we needed to migrate. And now we are going to be doing the migration itself, the migration plan. we are going to be migrating, we are going to be now selecting which network map do we want to use, the one that we have created, which storage map do we want to use. This allows us to have multiple network maps, multiple storage maps. And when we do the migration plan, that's what is going to drive how many VMs or which VMs do we want to include. So if you see back here, here we are going to be migrating one VM, this one, using this network map, this storage map. If we had 100 VMs in here, they would be migrating using exactly the same thing. But this is how you can accelerate. Now, what is the typical bottleneck in this migration? Is going to be the speed and the fact that you need to turn them off while you are migrating those VMs. So you likely don't want to spend a lot of time per migration, and the migration typically becomes a little bit smaller, that you don't want to migrate 100 VMs because you don't want to have a long time where it is unpredictable which machines are going to go down, which machines are going to come up. We typically recommend to test multiple speeds because it depends on the read speed out of your data store to do the conversion. Test multiple speeds and see how many can we migrate per execution, and then from there you can plan. After the VM, the migration plan is created. As you can see, the network map and the storage map has been applied. And now the only thing that we need to do is to click on the start button, and it's going to start migrating all the VMs in that migration plan. In this case, we only have one, so we can save some time. Once the migration starts, it's going to migrate the VM, and we will see it doesn't take a very long time. This is a very small VM. It converted very quickly. This is a video, not the real life speed, but the still is quite fast. Once the database is in this side, this is a CentOS machine. As everything in OpenShift, everything is YAML. Once the machine is there, we can start it. We have very similar controls to the ones we have in any other virtualization platform. And here we can start. We have a way to look at the console. We have a way to migrate the box. In this case, is one of the limitations that I was referring earlier. We can do the live migration, that is the same thing as a vMotion, because our storage is not capable of providing that support. But on a normal installation, that is something that you should be able to do. And now the VM, we will see the VM starting, like regular VM starting. Lastly, so we have seen the foundation, we have seen the MTV migration, and now let's take a look at what happens when we want to onboard applications. At the end of the day, this is a cluster that should be able to support applications and VMs. Let's take a look at the scenario where we want to add a Kafka cluster, something that is quite common. And I want to deploy just the default Kafka cluster inside of an OpenShift cluster. So all we need to do is to come to our dev cluster, the reference that we have, and add the application that we want to deploy, Kafka cluster. We have these templates already built. So we use the template that we have built to deploy Kafka. In the case of a customer environment, we would customize these operations, our templates to the customer needs. So when we want to onboard applications such as Kafka or any other database or any other queue or any other service that we have, is a matter of customization of the values YAML, and now we can just push, and it will automatically deploy Kafka and make it ready in the cluster. Not only will it deploy, but it will also observe that it doesn't deviate from our desired configuration. So if something happens in the cluster and somebody managed to modify what we have running, what we have identified as our validated configuration, it will override it. So if we go now back to see our tenant, we see that we have now a Kafka cluster that is getting created, that is a pod. So that's the first pod. Let's take a look at the GitOps. And now we change to the proper application. And that is Kafka creating everything that Kafka needs to deploy. Now, as you can see, Kafka is not the simplest deployment in the world. It has a lot of components. It has the Visium, the schema registry, everything that is needed or desirable to have a Kafka cluster. In this case, just using the template will deploy it all for us. Now, I know that it was a lot, and I went quite fast, and is not at the basic level. So let's take a look at what we are seeing and why is it important. As a reminder of what Todd was mentioning earlier, these are validated numbers, by the way. This is numbers that I have seen in previous engagements. So this is what we were what we were able to do to get out of in a real live installation. The 85% was here, and we retire 5% of the workloads. We didn't do any rehost to a different platform. We did retain 10% inside of VMware. So the VMware got reduced significantly to just 10%. For anybody who's thinking, what is that 10%? That 10% were machines and VMs that were very integrated into the VMware world, and they were not easy to move, and they decided to keep it running inside of VMware. It can apply to you, it may not. These are typically very, very particular workloads that are not worth to recode or to redo, and that eventually will disappear. We focus on the 85%, that is the area where we can have an impact and what we can do. This 85% goes into replatform, repurchase, and refactor. And depending how deep do we want to go into the analysis, we can come into the first level, that is the replatform, VM for VM. There is not much thought processing here. We take a VM out of VMware, we host it in OpenShift. That's what we just did. There is some analysis to be done on as far as network, storage, DNS, resolution, access. There are some complications, but it's a shallow analysis. Versus the other two options that are the repurchase and the refactor. Refactor meaning that we are going to take the applications that you have, we are going to take a look and see how much can we containerize. This is for homegrown application as well as COTS. In the case of repurchase, meaning that you have some vendor and you decide to either replace the vendor with another one that provides you a container solution, or the same vendor has a VM and a container solution and you decide to move to the vendor. If we look at this from a different angle, what we will see is that the deeper we go into the analysis, the better we get in the cost efficiency. If we assume that retain is doing nothing, we just keep it wherever it is, and we start doing rehost, retire, replatform, repurchase, refactor, we'll see that the closer we get to the cloud native, the more efficient we are, because the container's footprint is going to be smaller than the VM, and we are going to be able to get more out of our hardware. Considering the hardware prices and the situation that we have, this is something that we have seen a spike in interest. While before, everybody was so focused on the VMs only and just moving away from existing vendors, now we are seeing more customers interested in how can I get extra efficiency in my applications, and going into the refactor as containers route. Now, you don't have to take the entire thing in a single bite. Many people start with a virtual machine and then move into containers. So back to the previous slide, we would do the first lift and shift, get rid of the main urgent pain, and then after we consolidate, we can start doing refactoring of applications and moving those VMs from the OpenShift virtualization into containers. OpenShift gives you a single platform that is capable of running VMs and containers. So single operation, same screens, same operations, same deployment, and you can run both of your workloads. So if we go into why containers, for anybody who has not been exposed to these containers have, I like this slide a lot because depending on who you ask, they see containers in a different way. For applications, the typical challenges with applications is that my environment doesn't look the same from one environment to the other. I'm in production, it doesn't work. In QA, it does work. What's the difference? Well, with containers, we managed to simplify this a little bit, and we package the configuration inside of the container so the container and libraries go together. Container, libraries, and dependencies create a unit of work. And that helps to developers, it helps infrastructure, it helps everybody. From an infrastructure perspective, it allows us to get away from having to manage libraries for applications, having to step into that middleware portion. So all we care is that there is a host that it is up and it's ready to receive containers, and we can deploy observability to deploy across all containers instead of having to manage VMs. I have two more slides. This VM versus containers, this is what I was referring to as how do we get more efficient? Where is this efficiency coming from? The efficiency comes from because we don't have to care so much for VMs with named VMs that are long-lived. We make the switch to treat them as containers that are expendable. A container running inside of Kubernetes is called a pod, and a pod needs to be self-sufficient. It needs to self-heal. It needs to be observed. It needs a series of things that to VMs we used to do manually. Now, with the move to containers, that's where Kubernetes OpenShift provides that extra value. So if we go to look at how does it work? Well, if we look at OpenShift and a microservice, well, why do I need OpenShift or Kubernetes for a microservice-oriented architecture? If we don't have OpenShift, we need to start thinking about all of these things that surround the microservice and provide it in somehow. This is back to my own experience. Before I started working with OpenShift, we were building all of these things individually and then having to support and maintain it until OpenShift made the switch from cartridges to Kubernetes, and then it was a moment of light switch. Now I don't have to do all of this. I don't have to worry about the scaling. I don't have to worry about self-healing. I don't have to worry about load balancing. So from an application perspective, this was a lifesaver. And now we want to have, we can have some of these things for VMs. If we replace the VM, the microservice with a VM, we still have all of these other things surrounding the VM that provides that automatic self-healing, that automatic management of the VM. And now this is the last slide. I saw you some of these things today with our configs, with our repos, with our GitOps. This is where we gain scalability. This is how we manage to onboard a huge number of VMs or a huge number of applications, and how do we support a huge number of clusters with not infinite amount of resources. This works for us. We can help you to define something like this. You may have something like this already. This is something that for us, it changed the way we can do this type of effort. Todd, do you want to take it back?
Yes, thank you very much. Can you hear me?
Yes.
All right, let me just get this back up. We only have a few minutes left here. And turn off closed caption here. All right, so Hey, that was great. Thank you, Jose. Always interesting. I always learn something new every time I look at these different things. That was amazing on the way that we deal with that, and we'd like to, help you guys with your migrations as well. So before we close, let's talk about the offer. This limited time offer, if you sign a migration agreement with Options IT or Crossvale by April 30th, 2026, that's 7 weeks from now, we will migrate 20% of your virtual machines at absolutely no cost. So if you have 5,000 VMs, we're migrating 1,000 of them. We're going to do is, we're going to work with you on the 5,000. We're going to take 20% of that off from your cost. Full discovery, wait planning, migration, execution, validation at zero charge. We are putting skin in the game here. We are confident that we can help you get where you need to go very quickly. Even if you're not ready to commit to a full migration today, leave you with these two things. First, the pre-discovery workshop, 2 hours, no commitment required. We deploy automated discovery against your VM estate. Take a look at what you have going on there, provide you with an inventory complete score, regardless of what you decide to do. Second, the VM migration checklist. Work with us. Reach out, go to crossvale.com, and you can go to contact us, reach out and say that you're interested in talking to us about our VMware migration checklist or our free discovery workshop or the 20% off or 20% of your VMs migrated at no cost. Ready to start? We're ready to help you. Reach out today. And just a few minor things left. This is a decision that you need to make. The platform landscape has changed. Whether you stay on VMware with an authorized Pinnacle partner, modernize with us on Horizon Private Cloud, or find another path, you will need a plan. Organizations that have a plan today will have control. Phased migration, everyone else will be scrambling in 2027. There's deadlines in 2027 that are going to affect things if you wait. There's a better way to execute. The factory model makes it faster, more predictable, and less painful than the industry traditional approach, or DIY, you trying to figure out how to do this yourself. Leverage the resources that we've already done this many times. We know how to do this. You have a partner. Number three, you have a partner who covers all three options. We can help you regardless of what your situation is. If you want to stay on VMware for a while and then do some modernization, you're ready to do some modernization now, or you're just trying to figure out how to come up with a plan. It's a real offer that's out there. We want to help you. Options IT and Crossvale together provide you with a complete solution. I'll send this deck out. I have plenty of resources attached to this deck also, where a lot of this information was able to be pulled, either whether it's from our own resources, from what we've done in the past, or public resources that are out there that are verifiable. I thank you, everybody, for showing up today. I think we're at the top of the hour. If there are any questions, let's see if we can take them now. I didn't see any questions in here. Nope, no questions at this point. So thank you guys very much. You have a wonderful day.